Hello, today we're going to see the momentum. Okay, first past year question like this. Okay, you need to see this is 20 times 60 seconds. So this one is change in momentum. Okay, and then question asks for average force. So we need to calculate the average time first. So 60 seconds over 20 seconds, we will get 3 seconds. Okay, we explain first. Force equal to mv minus mu over t. The mv minus mu is change of momentum. So 4.2 divided by 3 directly, we will get 1.4 Newton. Okay, now we look at about the multiple choice question. Okay, you see the momentum. Actually, this one is before mu. Okay, now question say after rebound, you have same speed which opposite direction. So this one is mv. So we need to have change in momentum. Will be mv minus mu. So mv change in momentum in opposite direction. So negative 35 minus 35. So negative 50 kg meter per second. Okay, this one must remember, be careful of the direction. Okay, now calculate the force. Same as previous one. 50 divided by time. But this one is millisecond, so 0.05 millisecond change to second. So we will get it is 1000. Okay, following question. Okay, so momentum just leaving the girls. So just momentum actually is P and V. So mass 4, the speed is 12. So 48 kg meter per second. It is straight forward. The next one, average force. Still the same thing. Force equal to mv minus mu over t. Because initial is 0, so we can ignore it. So 48. Actually it's minus 0, so we ignore it. So the time 0.6. So we will get it 80 Newton. Now for next question. Okay, want to write the equation in terms of mu and v. Change in momentum. So change in momentum. Change of momentum just equal to mv minus mu. Final momentum minus initial momentum. Okay, now in the game. Okay, now question asks for impulse. So the impulse will be Ft. So force 400. Time, be careful, is millisecond. So we need to change to second. 0.006 second. So we'll get it is 2.4. Okay, what is the unit? Force times time. So Newton second. Because we multiply. Okay, calculate the speed after lift the racket. Okay, so we need to know. Okay, this one we need to use Ft equal mv minus mu. So means that impulse is same with change of momentum like now. Okay, impulse we calculate everything 2.4. The mass. What is the mass? Okay, 0.056. V we don't know. Initial is stationary, so minus 0. So we will get the answer. V will be 42.86 meter per second. Okay. this one. Speed. Okay, kinetic energy, what happened? See, it's same speed. Energy is scalar, so no change. Momentum is change because direction change. Next question, the question like this. Okay, calculate the momentum mv. So 70 multiplied 20, so 1400 kg meter per second. And now next is the problem impulse. Because we don't have the force, so we use mv minus mu. mv minus mu. So final car is stopped. So minus this one. So actually is same value 1400. Okay, you can put negative actually because the final is 0. Okay, next question, momentum of A. So momentum equal mv 6000 multiplied 5. So straightforward 30,000 kg meter per second. Question, calculate the impulse for mv minus mu because we don't have force. You see this one is after. Before is at rest, it's not moving, stationary, so 0. So the final one will be 27000 minus 0. So still the same. So kg meter per second. Okay, this one final speed for A. Okay, I use the formula list down here because they move in different speed. So m1 u1 plus m2 u2 equal m1 v1 plus m2 v2. Actually these all are momentum. The first object, the momentum is this 30,000. At first B is not moving, so 0. So this one is after. So mass for first one 6,000. V we don't know. So this one is after correction for V. So after do the calculation part, you will get 0.5 meter per second. It is the